Well, now we've got a pendulum that swings 10 feet left to right on its first swing, and then on each swing following the first, the pendulum goes 4/5 of the previous swing. And then we have some questions. Let's get a picture of what this is. I'm going to draw a picture of this pendulum so I can see what's going to happen here. So it's going to start out, say, to the left, and then it's going to swing this way over here, right? So it makes that first swing down here. So I'll draw that one. Makes that first swing like this, and this is how far here? Well, that's 10 feet. And then it's going to come back. And when it comes back, it does not come back all the way, right? It comes back just part way. So maybe it comes back, like to here. And what is that? Well, that is going to be, now we're told up here, that is, right here, 4/5 of the previous swing. Now it says 4/5 of the previous swing. The previous swing was 10. The of means time, so this is going to be, this distance here is 4/5 of 10. Then it's going to go from here, from left to right again. So now it's going to come back over this way. Let's see if I can draw that. It's going to come back over this way, but not all the way. So it's going to come back over here like this, and that's going to be what? Okay, we're getting a little tight here. What is this going to be? This one here is going to be, well, we're told it's 4/5 of times the previous swing. And the previous swing is this. So this one is going to be 4/5 of the previous swing, which is this one here, which is 4/5 of 10. All right, now it's going to, we've got the, what? We have the okay. Now this pendulum is just going to keep swinging, right? Keep swinging smaller and smaller until finally it stops. So let's see, let's ask some questions here. Here's the first question. Write a sequence, right, for the distance traveled by the pendulum on the first, the second, and the third swing. Well, we just happen to have found those, so let's do that. So for part A, first swing was 10. The second swing was 4/5 of 10. And the third swing was 4/5 of that 4/5 of 10. Let's see what these are. We'll get 10, and then what do you get here? Well, 5 into 10 is 2. 2 times 4 is 8. And then what do we get here? Well, we just found that to be an 8, right? So let's draw this out. This is going to be 4/5 of 8. All right, so here's part A. 10, 8, and 4 times 8 is 32 over 5. So the first distance it traveled, now I'm down here at the picture. The first distance traveled from here all the way over here was 10 feet. Then it traveled 8 feet. Then it traveled 32 over 5 feet. Now, 32 divided by 5 is a little bit more than 6. And now part B asks us to write a general term for the sequence where n represents the number of swings. Okay, let's get an idea of how to do this by writing out everything that happened. So for part B, here's what we had. For n equals 1, this was just what? That was just 10. Okay. What about n equals 2? On the second swing, it was 4/5 of 10. Now what about the third swing? All right, n is the swing number. So at n equals 3, we had, okay, 4/5 of 4/5 of 10. Now 4/5 times 4/5, I can write that as, how about 4/5 squared times 10? And then what about n equals 4? I think we'll see the pattern here. At n equals 4, it's going to be 4/5 of what? The previous one, which is this one right here, right? So it's going to be 4/5 of 4/5 squared times 10. But 4/5 times 4/5 squared is 4/5 cubed times 10. Now we're probably seeing the pattern here. What do we have for n equals 1? Well, we just have 10. For n equals 2, we got one of those 4/5. For n equals 3, is 4/5 to the second power. For n equals 4 is 4/5 to the third power. So it looks like we're always going to have something like 4/5 times 10, and the power is just one more than the term number. So I'm going to write a general term now. The last question says, how far will the pendulum swing on its 10th swing? So we're looking for a sub 10. I'll do that down here at the bottom left here. So we want a sub 10. That's the distance on its 10th swing. So a sub 10 is, well, what is a sub 10? Well, look over here to the general term. This gives us any term at all. So a sub 10 is going to be what? 4/5 to the 10 minus 1, right? The 1 just before it. So this is a recursion formula. So it's going to be 4/5 to the 9th times 10. All right, and I did that on my calculator, and I came out with this. I came out with 1.3421 dot, dot, dot. But what we're supposed to do is just round to the nearest hundredths. All right, so I got tenths, hundredths. That's a 2. So I'm just going to drop and write this as 1.34. So the distance on the 10th swing will be about 1.34, well, 1.34, and then what am I going to write? It doesn't say to write a sub 10. It just says, what is the distance? Well, the distance is 1.34 feet, right? The answer is not a sub 10 equals 1.34, but rather just 1.34 feet.